Since we now have studied a little bit about incenters and circumcenters, meaning the point of concurrency of the angle bisectors and the point of concurrency of the perpendicular bisectors, let's look at three problems using bisectors in triangles. So in this first problem, we have the triangle ABC, and we've been given three perpendicular bisectors, the segment LD, the segment MD, and the segment ND. We've also been given that the length of the segment BD is 13.4 and the length of the segment MD is 7.3. Let's mark those in our diagram first. And now what we're here to find is the length of the segment CD. Since D is the point of concurrency of the perpendicular bisectors, meaning the circumcenter, we know that the point D is equidistant to each vertex. And therefore, the length of the segment AD, the length of the segment BD, and the length of the segment CD are all equal. And since we know the length of the segment BD, we can substitute that in and find that the length of the segment CD is also 13.4. Now in our next problem, we have the triangle GHJ, and we have Z as the circumcenter of that triangle, reminding ourselves that the circumcenter is the point of concurrency of the perpendicular bisectors. We have four different measurements also. We'll mark those in the diagram in just a few moments. But let's look at what it is that we're out to solve for. We're out to solve for these three lengths. Let's mark those in bright yellow so we know that as we mark the diagram, we will know when we've answered the question. Now, because Z is that circumcenter, we know that it is equidistant to each of the vertices. And so we're going to mark the diagram with the fact that one of those lengths is 19.9, so all three of those lengths, the length GZ, the length HZ, and the length JZ are all 19.9. You'll notice that since we've highlighted this ahead of time, we know that we've already answered one of the questions. We also know that, as we discussed earlier, that we have those three perpendicular bisectors. And it's not the perpendicular that's important, it's the fact that it bisects each of the three sides. So, since we know that on one of the sides, half of it is 18.6, the other half is also 18.6. And similarly, since we know that MJ is 14.5, we know that GM is also 14.5. And now we can see that we've got numbers we've solved for those three highlighted segments, so we've actually answered the questions here. Because from these markings we know we have the answers. That the segment GM is 14.5, the segment GK is 18.6, and the segment JZ is 19.9. What's important to note here is that we were given this segment length of LZ is 9.5, but we didn't need it at all for this problem. We can go ahead and mark it, but it wasn't necessary in solving this problem. And here's our answers. And in our last problem, we're given the triangle LMN, and we have two angle bisectors, the segment MP and the segment LP. We don't have the third angle bisector, but that's not necessary. Just doing any two of either angle bisectors or perpendicular bisectors will get us our center. The third construction is always kind of the checking that it is. So we know that we have angle bisectors, meaning that we know that P is the incenter of this circle, of the triangle, excuse me. Now, two things we're going to look for here. The first is we want to find the distance from P to the segment MN. And it's not marked here, but the distance would be this perpendicular distance right here. We want to find that distance. That's problem number one. Problem number two is that we want to find the measure of the angle PMN, which would be this angle right here. So these are the two things that we are looking for in this problem. Let's look at problem number one first of all. Since P is the point of concurrency of the angle bisectors, meaning it's the incenter, we know that the incenter is equidistant to all three sides. And since P is 5 units from the side ML, it must be also 5 units from the side MN. In problem number 2, we're going to be talking about all the different angles. And we know that the segment LP is an angle bisector of the angle MLN. So this angle right here has been bisected. And we know that half of that angle is 50. So by substitution, we know that the whole angle is going to be 100. So now we have two angles in this triangle. We have one of them being 100 degrees and the other one being 20. And so using the triangle sum theorem, we can solve for the third angle in the triangle and find that the measure of angle LMN is 60 degrees. So this entire angle right here is 60 degrees. With this angle bisector MP, we know that the measure of angle PMN would be half of that, and so by substitution, we know that the measure of the angle PMN is 30 degrees. So these were 3 problems using our knowledge of angle bisectors and perpendicular bisectors in triangles.